All right, so from that introduction video, you could see how to graph a linear equation and relate it to how to graph a linear inequality. So we're still going to be seeing inequalities just like equations are in slope-intercept form. You still have to plot the y-intercept. You have to use the slope to get to another point. But then things are going to change because now we're going to be seeing inequality symbols instead of equal signs, which will determine if your line should be a dotted line or a complete solid line. And then we're also going to be shading in certain areas to show that those are solutions. If you remember in chapter 2, I believe, when we were solving inequalities, we would have to solve the inequality and then graph it on a number line. Kind of similar to this in that we now have to graph these inequality graphs and then draw it not necessarily on a number line but on a coordinate plane now. So we could see there's two types of lines. So just on the side here, because there's not really a ton of notes, there's just kind of examples here. There's two types of lines, so we call them either solid or shaded lines. So solid lines, so that would just be like a line you're normally used to using. And solid lines are for less than or equal to or greater than or equal to symbols. And then dotted or dashed lines these are for less than or greater than symbols. So when we're graphing these inequalities, I know you're used to just drawing the y-intercept, the slope, and then drawing a sketch of your line. It's going to be different because now you might have to, instead of drawing a straight line like that, you might have to use a dotted line instead. In addition to that, there is also one other thing you have to do, and it's shade a region. Every time you draw a line on a graph, that line splits the coordinate plane into two parts. One of the areas is going to be shaded in, the others it will not be shaded in. The solutions that are shaded in are going to be all of the answers to the inequality. So inequalities have infinite solutions, which is why we have to have graphs. When you're solving simple ones like chapter 2, the graphs were just number lines. But now that we're actually graphing with multiple variables, it's going to either be one side of the coordinate plane or the other. So these examples here are showing us what the graphs of each linear inequality would look like. This one says x is greater than or equal to -3. And when we have any type of equation that starts with x, so if we just think about an equation for a second, if this was x equals 3, I know that that would be a -3. I know that that would be a vertical line at -3. So if we look here at this graph, this would be -3. I see the vertical line. Because this symbol is a greater than or equal to symbol, and greater than or equal to symbols are solid lines, I see that they made a solid line here. So it's a solid line, vertical, up and down at -3 on the x-axis. The last thing we have to do is then shade a region. So when we're shading, my favorite point to use is 0, 0. And I'm going to say when possible because you can only use 0, 0 if it is not a part of the actual line. Sometimes 0, 0 is a part of the line. And then you can't use 0, 0, but 0, 0 is the best point to use because it takes all the variables and just turns them to 0. Since there's only one variable here, and it's just x, and you would just replace this with 0, 0 is greater than or equal to -3. That is true, and since 0 is over here, that's why they shaded this whole region here. The region, I know it's on yours, it looks just black and white, but here the shaded regions are in green, and they're showing that those are all of the solutions. All of the numbers that are greater than or equal to -3 on the x-axis are everything to the right of -3. Same thing, but now we're doing y. The equation y equals 4, I know from the last sections, would be a horizontal line at 4 on the y-axis. I can see 4 on the y-axis here. It's a horizontal line. But the only thing that's different is now that this doesn't say y equals 4, it now says y is less than 4. We have to realize that we have to use a different type of line. That's why they have a dotted line here, not a solid line. Dotted lines are for less than or greater than symbols. And then anything that's less than 4 on the y-axis axis is anything below, which is why they shaded everything below here. So here's an example of a vertical line, a horizontal line, and here's what we're normally going to see. This this inequality says x plus y is greater than 3. If I give you an inequality and I say graph this, the first thing you're going to have to do is solve for y. So solving for y, I would subtract both sides by x, and I will get y is greater than negative x plus 3. Then you would go ahead and graph that. When you're graphing lines, whether they're equations or inequalities, the first thing you would do is graph the y-intercept. If we look here at this graph, the y-intercept is at 3, so it would make a point. Then you would use your slope. In this case, this says negative x, which is really a negative 1 over 1. You would use your slope to get to at least one more point to make your line. A rise of negative 1 means go down 1. A run of a positive 1 means go to the right 1. So from 3, we go down 1 to the right 1. And you can keep going, down 1 to the right 1, like that. Now, the only thing about inequalities I keep trying to stress is that because it's not an equal sign and we have a symbol, we have to determine if the line will be dotted or solid. Because it is a greater than symbol and it's not greater than or equal to, you would have to use a dotted line, which is why they have this dotted line here and not just a line straight through all of the points. After you have the line completely drawn, now the last thing you have to do is test a region. This line splits up the region into two areas, below the line and above the line. What you will do is use the point 0, 0 to see if it is true or not. If it's true, then that means that area that 0, 0 is in is a solution region. If not, it's the opposite. So you can use the very beginning inequality. So if I use this right here, x plus y is greater than 3, I'm going to use 0, 0. So I'm going to put 0 in for x, 0 in for y, and see if this is true. 0 plus 0 is 0. I don't know why this is messed up. Is 0 greater than 3? No. 0 is not greater than 3. Since 0, 0 was in this region below down here, that means this entire region is false. Since this is not true, this entire region of points is false, which means that if that is false, this must be true. So you would shade the above region. So this is kind of what happened in that video, that introduction video that you saw. And there's just another recap here. So the last thing that we have here on the notes just goes over sketching the graph of a linear inequality. So number 1, replace the inequality sign by an equal sign to help you sketch the graph. Then make sure to either use a dashed line or dotted line for less than or greater than, and a solid line for less than or equal to or greater than or equal to. Then test one point. I think the easiest point to use is 0, 0 to figure out which side of the line should be shaded in. If you get a true statement, that means shade the side that has 0, 0 in it. If you get a false statement, shade the opposite. So, if we're going to try this one on our own or together, sketch the graph of the linear inequality 2x plus y is less than or equal to 2. The first thing we would do is pretend this is an equation so we could graph this. 2x plus y equals 2. I personally like to graph in slope-intercept form, so I can take this equation, I can solve it for y, and then it will be in slope-intercept form. That means I would subtract 2x from both sides. I'm going to get y equals negative 2x plus 2. Once I have this equation ready to go and solved for y, then I can start graphing it. My y-intercept is this number here. So on the y-axis, I'm going to make a point at 2. My slope is here. Because it's a negative, I know that this line is going to be going down. I'm going to start at the y-intercept and then go down 2 points or 2 units and over 1. So you start here, go down 2, 1, 2, over 1. Down 2, over 1. Down 2, over 1. My line's not perfect, but yours will be better. Now that I have the points that I need, where you only really need 2 points, but now that I have some points to make the line, your next thing to do is determine if this is a solid line or a dotted line. And you determine that by looking at the symbol. The symbol is a less than or equal to symbol. Because it has that equal to part of it, it will be what type of line? Solid. Yes. So it's almost like an equation. It looks just like an equation right now because it's a solid line, and solid lines work for less than or equal to or greater than or equal to. The last thing we're going to do is determine a point that we would like to test to see which area is shaded. This line splits up the coordinate plane into two parts, the part below or the part above. I personally like to use 0, 0 to see if this area down here is the solution or not. 0, 0 is the easiest to use because when you replace 0 in for any y or x, you don't have to do any math. Everything turns into 0. Since 2 times 0 is 0 and 0 plus 0 is 0, this whole thing will always just be 0. And then you just see if this is true or not. If 0 is whatever compared to whatever number. 0 is less than or equal to 2. This is true. Because this is true, that means that every single point in the same region that 0, 0 is in is also a solution, which means the shaded region is everything underneath the line. Now, your shading doesn't have to be perfect. It doesn't have to be like actually coloring the whole thing in. You could just scribble like that just to show me that it's below the line now. Any questions so far? All right, so I think we're going to do maybe one more example before we move on. Flip the page over to the next side. Two more examples. So we're going to be graphing these two problems. So x minus 2y is greater than or equal to 6, and then 3x minus 2 is less than or equal to 5x plus y. Now, both of these are kind of difficult in their own way. So what I'm going to do is help you set it up, and then I want you guys to try graphing these on your own. Setting it up means take the inequalities and first solve them for y. So if I was going to take this one to graph it, the first thing I would do to solve for y is subtract both sides by x. When I do that, I'm left with negative 2y is greater than or equal to negative x plus 6. The last thing I'm going to do is get rid of the number in front of y, which is negative 2, and I'll do that by dividing both sides by negative 2. The only thing about this is when you divide by a negative, the inequality symbol flips, so you have to be very careful. The inequality was greater than or equal to, it flips to be less than or equal to because I divided by a negative 2. This is a negative 1x divided by a negative 2. That's going to turn into a positive 1 over 2x. This is a 6 divided by negative 2, which is a negative 3. So this is the inequality you would graph for the first one, which we're going to skip the graphing part for now. And I'll help you set up the second one, and then you guys can try the graphs on your own. The second one is a little bit tricky as well because we have variables on both sides. We have the 3x here and the 5x here. We need all of these x's to be on the same side. Because we have y on the right-hand side, I know I don't particularly like to have negative number of x's, but I'm going to subtract 5x so the y is isolated by itself. It'll just be on the right-hand side, which we're normally used to seeing it on the left. But we can flip it then. 3x minus 5x is negative 2x, minus 2 is less than or equal to y. This is a little bit confusing for me. I prefer to have the y first. So if I flip everything around, this will be y here. This will be negative 2x minus 2 here. Just make sure when you do flip everything around, the symbol flips with everything too. So it would be that. So what I want you guys to do, we have 3 more minutes. Please graph and shade both of these problems. We'll go over the answers before we leave today. If you need more practice, I do have a Quizlet uploaded in Schoology. We won't have time to do it in class today, but if you need more practice after today's lesson, it will be up and available for you. So I'll give you a couple minutes. We'll go over the answer before we leave.